Professor Nakamine, please.
Yeah, thank you, Tananit. It's my great honor to be here and make my presentation about the new PS TKA for Thai and Japanese. So the Japanese name is Future Knee. So our first question is, why do we need TK system for Asian people? Actually, I was in the United States since 1990 to 1991. I was research fellow at the Biomechanical Research Laboratory in the St. Louis, Missouri. So my boss was Leroy Whiteside. He was a big name in the United States. You can see his hospital was located in the St. Louis, Missouri. That's the center of the United States. And all patients were typical Caucasians. So this is the one TK case in the United States. So I think it's almost normal. It's okay. It's a typical TK case. So this is the Dr. Shimaru's. This is in India about 8 years ago. He presented one case. The patient was 59 years old, and he was a professional golf player, and he complained with a right knee pain. So you can see the X-ray on the right knee. And he did the TKAs. So he said that the TK should be done before the knee joint is destroyed in order to maintain the proprioception of the knee. So when you think about the knees in the United States and Europe, 3 degrees is a very important angles. So the tibia is symmetrical, and if you rotate the femoral component 3 degrees relative to the posterior condyle line, all cut surfaces are automatically set perpendicular to the mechanical axis. I think it's easy. So this is the typical Japanese OA knees with the Varus deformities. So we thought the size and the shape of the bone are totally different between Asian people and the people in the United States. So you can imagine in Asian town, you can see like that. So the old American car is too big and is not comfortable in Asian town. The same thing in the Asian knee, American TK was not suitable and not comfortable. So the one reason is that the too much food in the United States. So this is a steak, it's named tomahawk. So 800 grams. Can you eat, Dr. Kim? So I checked the body weight and height in 6 countries. You can see the Korean people and the Taiwanese almost same. And the Thai and the Japanese are almost same. And the French is 1 size larger than us. And the Caucasian are 2 sizes larger than us. So when you think about the cause of the OA, in the United States, the alignment is normal, but the heavy weight will destroy the knee. In Asia, the Varus deformity will destroy the knees. So the cause of the OA is different between Asia and the United States, and bone morphology is different among Asian countries. So we must think about the way of living too. In the United States, table and the bed. And this is the very famous animation Sazae-san in Japan. You can see the way of living in Japan. And this is the one lady praying on the floor in Thailand. So in these situations, external rotation in right leg and internal rotation in left leg. So the wide rotational flexibility is necessary in flexions. So this is the paper of Ali. He reported that the Thai female knees have a highest incidence of hanging of the femoral component. So the question, why do we need TK system for Asian people? The answer one, shape of the bone are different between Asia and the USA. So the components to fit the Asian patient are necessary. And the way of answer two, way of living is different between Asia and the United States. So design to obtain deep deflection angle safely is necessary. And we had 3 steps to develop the optimal TKA for Asian patient. The first step was to clarify the anatomic variations of the Asian knees. So this paper was published in 2000. The title, The Anatomic Variations Should Be Considered in TKAs. So what we found was that the characteristics of the Japanese OA knees are lateral bowing and anterior bowing of the femoral shaft, the proximal tibia vara with the medial shift of the tibial surface, and the medial torsion of the tibia. And then lately, we found that the posterior rotation of the tibial condyle with posterior shift of the tibial surface. So this is the femur and the tibia in typical Japanese OA knees. So 2003, we published one paper about the medial torsion of the tibia. So this picture was in my paper, but she is my daughter's. About 18 years ago, that was the first and the last time to ask my daughter to sit straight. So this is the one cause for the medial torsion of the tibia. And lately, you find that the tibial posterior slope is mainly created by the posterior rotation of the tibial condyles. You can see one case with no posterior slope, the another case with larger posterior slopes. So if you superimpose like that, the anatomical axis is the same, but you can see the difference between the mechanical axis between two cases. So we are now proposing the concept of the constitutional posterior rotations. And 2012 and 2013 and 2016, people are now thinking about the anatomic variations about the Asian knees. So step one is done. And the next step was to establish the operator technique for Asian knees. So this is published 2003. We established the modified gap control technique, and we recommended the PS TKA. I think the combination of these two is the most reliable technique to obtain soft tissue balancings in any knees with anatomic variations. In 2004, our paper titled Distal femoral cut perpendicular to the mechanical axis may induce Varus instability inflections if the femoral shaft has lateral buoyance. So we established the operative techniques to prepare the anatomic variations. So this is the paper of Professor Mraj in India, reduction osteotomy. It's very important technique to correct the Varus deformity and to match the new mechanical axis after the reduction osteotomy to the anatomical axis. And 2011, this is a paper titled Effect of the Medial Soft Tissue Releases during PS TKA. So we established operative technique to obtain soft tissue balancings. So the second step was done. And the last step was to establish the design of the component for Asian knees. The first step, to fit the bone of the Asian patient and to make a design to minimize the contact stress. So we established a database for bone morphology in Asian people, and the Japanese government supported us. And we measured many parameters using CTs like that. And this morning, Professor Sataya made a presentation about the three-dimensional assessment of the distal femoral morphology in Asian populations. So we got the component design suitable for thigh. So this is the result of the comparison of the Japanese and the Taiwanese. You can see Taiwan and Japan is very close, but the AP-ML ratio is totally different. So the next step is to make a design to minimize the contact stress. So we did the 3D finite measurement model analysis like that to get the design to have the minimum contact stress. And this is the result of the equivalent stress, which means the contact stress of the condyle with 10 degrees internal rotation of tibia during inflections. The new means future knee. And this is the equivalent stress of the post with 10 degrees internal rotation of the tibia. So the last step was done. And then we established research project. The NEDO is a new energy and industrial technology development organization, a part of the Japanese government, supported us. And also MTEC, a National Metal and Materials Technology Center in Thailand, supported us. And then we established the future knee, PS TKA systems. This system is to prepare the anatomic variations and get wide rotational flexibility in deep inflections to sit on the floor and maintain stability throughout deflections. And friendly patellar group to prepare any external rotation of the femoral component. And post and come engage at about 70 degrees of flexions. And then November 12, 2016, we did a cadaver test in Chiang. So Professor Sataya supported us. So I'd like to thank Professor Sataya. So the purpose of the cadaver study is to assess the knee kinematics with the feature knee and to check feature knee has all we needed. So we tested 5 conditions. The condition 1, normal, and condition 2, after ACL cut, and condition 3, PCL cut, and condition 4, after TKA with CS insert, and condition 5, after TKA with PS insert. So we check the flexibility like that. And this is the result of the Varus and valgus flexibility, the normal and ACL cut, and the PCL cut. You can see after the PCL cut, the knee has severe instability. And with CS and the PS, the result shows that the implant knee was very stable during knee flexions. So this is the result of the internal external rotational flexibilities. You can see, and please take a look at the result in deep knee flexions. The knees has enough rotational flexibility in deep flexions. This is the AP movement. Because the PS system AP movement are a little larger, but it's acceptable in the clinical situations. So we also check the knee kinematics. The feature knee shows the same external rotation of the femur with the normal knees. And this is the result of the Varus and valgus angle during knee flexions. You can see the red line. The tibia moves in one single plane during knee flexions. Also, this result also shows that the tibia moves in one single plane during flexions. So these results seem that show that the kinematics is great. And this is the result of specimen 5 with PS. You can see the movie shows the typical medial pivot pattern like that. So the result of the cadaver study shows that the feature knee had a great Varus and valgus stability during knee flexions, and have enough rotational flexibility in deep knee flexions, and seem to have acceptable AP stability, and has similar kinematics with the normal knees. So we decided to go to the clinical results, clinical trials. And so far we have more than 120 cases are done, and the clinical result is excellent. And the wear-resistant test was performed in MTEC. So the vitamin E was added to the polyethylene, and 5 million cycle tests were done. And this is the result. You can see the feature knee, the polyethylene has the great wear resistance. So in the summary of the development of the feature knee, we analyzed the design of the all commercially available systems, including the United States. And we established the design to fit the bone of the thigh, and established the design for minimum contact stress. And we assessed the knee kinematics by cadaver study in Chiang. And wear resistance that was performed in MTEC, the result is great. And the early clinical results are excellent. So we think that everything is packed in the feature knees. So when you think about the similarity between Thai and Japanese, you can see the length is a little bit longer in Japanese, but the AP-MO ratio is almost the same. So we conclude that we can use the same design. So why the same? So we must think about the origin of the Thai and Japanese. So our origin is the same, Thunderdont, Mongoloid, and the life on the farming, and the religion, Buddhism, residency on the floor. So we think same origin and the same way of living and the same culture have made the same morphology of the bone and the body. The feature knee PS systems, many doctors are supporting. So this system is filled with all kinds of the passion and the continued research for more than 20 years by so many doctors and technicians. So currently, the Ministry of Health and Labor and Welfare, this is Japanese FDA, has approved feature knee. And the clinical trial has been done since October 2017. And the feature knee will be commercially available, which means everyone can use in Japan in this month. And we have got the support of the Japanese government for the preparation in Thailand. And we are now going to get the approval in Thailand. And finally, on behalf of the Japanese staffs, we would like to thank Professor Sataya and all members who support the development of the feature knee. Thank you very much. Thank you.